In the last class, we discussed the elements of the multi-step synthesis. So the fifth element is the activating group. Activating group means the sum of the group which activate the chemical reaction. For example, in an electrophilic aromatic substitution of a monosubstituted benzene is faster than that of benzene under the same condition, the substituent in the monosubstituted benzene is called activating group. I am quoted the nitration on the benzene ring of the benzene ring, and we are comparing the rate of the nitration of the benzene ring with the substituted benzene. See here in the first one, benzene, the total rate is only 6. But if you are substituting methyl group, the rate is increased to 147. Again, if you are substituting CCH3, it is decreased. But when we are comparing the benzene group, the CH3 and CCH3 thrice are activating group. That means these groups are activating the nitration. Since this group are donate electron, that's why this electrophilic nitration of the benzene is activated by the presence of methyl and CH3 group. That's why the methyl group is known as activating group. Whereas in the case of chlorobenzene, if you are substituting the chlorine, the rate of a reaction is decreased to 0.20. So the chlorine is act as a deactivating group for this particular reaction. So similarly in the CO2CH3, again the rate is decreased to 2.02. So these two groups are known as deactivating group. So any group which activate the particular reactions are known as activating group, and any group which deactivate the particular reaction is known as deactivating group. Next, we are moving into the sum of the substituent. So again I am repeating, activating group increases the rate of a reaction and deactivating group decreases the rate of the reaction. Activating group tend to donate the electron density to the ring, and deactivating group withdrawing the electron density to the ring. I am quoting the sum of the functional group, and some of the functional group are strongly activating groups, but some of them are only activating group. So these functional group, we have to find out the functional group depending upon the chemical reaction and selected chemical reaction and the other condition which are required for the chemical reaction. But some of them are deactivating. A few of the functional group are strongly deactivating the multi-step chemical reaction. So we have to aware before starting the synthesis, multi-step synthesis, we have to aware that which of the functional group are activate this chemical reaction and which of the functional group are deactivate the chemical reaction. So we can alter the speed of the chemical reaction or rate of a reaction, and we can monitor the reaction by using these type of groups. Now we are moving into leaving group. This is the next element in the multi-step synthesis. Leaving group means it is a molecular fragment that depart with a pair of electron in the heterolysis bond cleavage. See here, both the nucleophile and the leaving group are having the lone pair of electron, or they have the pair of electrons, but depending upon the size and their character, one are acting as a leaving group, the other one is acting as a nucleophile. So here the nucleophile is the bromine and OH group is acting as a nucleophile. When we are comparing the nucleophilicity of the OH minus ion and Br, the OH minus ion is the best nucleophile, and when we are comparing the size, the Br is in big size, so it is acting as a leaving group. Now next topic is the synthetic equivalent and synthon. First of all, we are moving into the example. After that, we will moving into the definition. So see here, this is a target molecule. So in order to find out the chemical reaction, in which way we have to proceed to prepare or synthesize or prepare the target molecule, we have to disconnect or cut the target molecule into different fragments. So this process is known as the disconnection, and this approach is known as the retrosynthetic analysis. These are we already discussed these terms. Anyway, we are repeating that term. So this arrow mark shows the retrosynthetic analysis. So while we are doing the retrosynthetic analysis in the target molecule, we are disconnecting the molecule in the in this part. The red line shows the disconnection, and while we are disconnecting, we will get the two fragments, the CH2 plus C6H5 CH2 plus C double bond OH. These are the fragments. These fragments is known as synthons, and these fragments cannot act as a common reagent, but we can develop this synthons into reagent. So the fragment of target molecule is known as the synthons. And if you are developing the synthons, you will get the reagent or starting material. That reagent is known as synthetic equivalent. So the synthetic equivalent means reagent which is equivalent to the reagent which is equivalent to the synthon. Okay, so if you are adding this reagent, we will get the synthons in the synthetic chemical reaction. So that is the difference. Now we are moving into the definition. So synthon is a generalized fragment, usually an ion or produced by a disconnection. But synthetic equivalent is a reagent carrying out the fraction of a synthons, which cannot itself be used, often because it is too unstable. So the synthetic equivalent is frequently asked university question. What do you mean by synthons and synthetic equivalent? Write the definition, explain with example, and point out some of the synthons and synthetic equivalent. Now we finished all the element which is used in the multi-step synthesis. We have discussed 8 elements in synthesis, multi-step synthesis. One is the reaction method, reagent, catalyst, solvent, protective group, leaving group, activating group, and synthetic equivalent. These are the tools these are the some of the elements or tool which is used in the multi-step synthesis.